Okay, hi, this is our circuit. First of all, we have a photoresistor that measures the amount of sunlight, which is what powers our drone because it uses solar energy. Here we connect the photoresistor to the Arduino and to the breadboard by using by connecting it to an analog for it to be able to have an input and an output, and we connected it to a 5 volt power for it to have energy and to be able to work. And we also connected it to the ground because it needs it to be able to work as well. Then we paired a LED light um, to its respective digital pins. So a specific color can show up when a specific amount of light is measured by the photoresistor. And we connected the LED light to the resistor that's connected to the photoresistor. Here you can see how we made it work through the code. We set a variable to be sunlight and to read the analog pin A5, which is the analog pin where the photoresistor is connected. Then we set our conditions. That is, if the sunlight is between 0 and 220, the LED pin will set to color red. If the sunlight is between 220 and 366, the LED will set to color yellow. And at last, if the sunlight is very high from 366 to 550, the LED light will be in the color green. Now here you can see how it works. Right now it's red because there's not a lot of sunlight. And as we move through the amount of light, it turns yellow, meaning that there is more sunlight. And now it's green, meaning there's a lot of sunlight. Perfect. Now we have our measure for temperature. Since our drone measures, makes weather forecasts, it's important for us to be able to have a temperature sensor to an analog pin so we can have an input of which would be the temperature around the drone, and we connected it to the power and to the ground so it works. And as well we used a LED light and connected the LED light to its respective digital pins so the LED light can work interacting with the temperature sensor. Now here you can see how we made it work with our code. um, we set a variable to be temp, which is like temperature. And then we set this variable to read the temperature sensor on pin A4, which is the analog where the temperature sensor is connected. And we chose units Celsius. And then we set our condition, that is if the output of, if the input of temperature is between 92 Celsius and 125, the LED pin will be a reddish color, and that would be its output. If the input is 59 Celsius and between 92 Celsius, the LED light will turn color orange. If it's between 26 and 59 Celsius, the LED will turn a color yellow. If it's between -7 and 26 Celsius, it will turn a color light blue, meaning it's beginning to be a little cold. And if it's between -40 and -7, it's a dark blue color, meaning it's really, really cold. And here you can see it work. Here it's a little bit cold and it's a light blue. Here it's super cold, it's -40 and it's dark blue. And as we go and up the temperature, it turns yellow, then orange, and then red. And it's as the hotter it gets, the color changes to a dark, like a yellow reddish color.
Yeah, and for our third circuit, we have to create a distant sound alarm. which consisted of a distance sensor and a piezo sound alarm. We had to connect a resistor to the negative side of the piezo, to the ground. And well, with the code consists of the variable distance, which is set to read the ultrasonic distance sensor on the trigger pin A3, and it measures the distance in centimeters. The first interval of distance is from 0 to 10, which is when things get very close to the drone. The main purpose of this is for the drone to know when things are approaching it and when for it to know if things are too close. And well, tone 60 for all, when it is between 10 and 50 centimeters, the sound will sound for 0.50 seconds every second. And the same with the interval between 50 and 100 and 100 to 150. Then this is how it would look like. Between 0 and 10, it sounds very fast. Between 10 and 50, it sounds a little bit slower, but still it is pretty fast. Between 50 and 100, it slows down. And between 100 and 150, it keeps slowing down each time. And well, that is because the closer it gets, it should sound faster, so it is more alarming and, well, more of an emergency. And well, our tilt sensor consists of two resistors and a LED light. The LED light is supposed to turn red if it detects something is tilted. This is meant for the drone to remain parallel to the ground. And where our tilt code just is set to read the digital pin in 2. If the tilt is greater than 0, so if there is a tilt, the light set at pin 13 will shine. If not, it will be set to low and will not be turned on. We can see it. We can see it here. There is no tilt, so the light is turned off. As we tilt it, it turns on. And that is all of our circuits.
Thank you.
Thank you.